Okay, so here's a question for you. What could possibly link ancient Greek marriage rites, a 27.7% energy saving in some new AI hardware, and that really awful feeling of being completely misunderstood?
Wow, that's quite a mix. Sounds less like a connection and more like just random concepts thrown together.
Exactly. It seems like a collision. But today, we're actually going to show how that collision is, well, a kind of perfect alignment.
Okay, I'm intrigued.
Yeah, so our mission in this deep dive is a bit different. We're looking at a set of sources that are intentionally interconnected. And the really interesting part, we're using the very tools they created to analyze them.
Ah, so using their own lens, like their conceptual framework to understand the material itself.
Precisely. We're tracing this, well, frankly, profound and maybe accidental alignment between a very subjective lived experience, that's Dennis Verhage's neurodivergent model, and some really objective cutting-edge engineering, specifically Tom Hennigan's PASTA project.
Right, the subjective meeting the objective and finding common ground
Well,
in
yeah.
AI.
In AI, yeah, but also in mathematics and, believe it or not, philosophy.
Mm.
The tools we're using are implicit Q-learning IQL and this wonderful Dutch concept, the Esel-Bruggetjes,
Mm.
the mnemonic bridges.
Mnemonic bridges. Okay.
Let's start with the software side first, the IQL.
Okay, sounds good. So IQL, implicit Q learning. The project we're talking about, PASTA, uses it. It's a type of reinforcement learning, RL.
Right, RL, learning from rewards.
Exactly. The core idea is learning actions to maximize some kind of cumulative reward over time, but IQL adds a twist. It focuses on implicit preferences.
Implicit, meaning stuff the system figures out about you even if you didn't, like, explicitly command it, or maybe didn't even realize yourself.
That's the idea. It's designed to maximize cumulative satisfaction over many, many interactions by really understanding a user's unique individual tastes.
Okay, so how does it handle something super subjective? The sources use the example of an inside joke. How can AI get an inside joke? That seems like the ultimate subjective thing.
Well, that's the perfect test case, isn't it? An inside joke has zero objective value. Its worth is entirely based on shared history, context, that subjective stuff. IQL is specifically engineered to find the value in that shared personal history. It looks for patterns in that context-rich data.
But wait, if it's all subjective, how does it know it's learning a real preference and not just, noise or some random thing I liked once?
That's a great question, and that's why it needs to learn implicitly across multiple turns. It's not just one reaction, it's looking for the consistent pattern of reward, the underlying preference, not just a fleeting whim.
Okay, that makes sense.
And this connects directly to the sort of human struggle that the system validates. The sources talk about the autrovert, that's the term used.
The autrovert.
Yeah, someone whose internal world is complex, maybe highly efficient in its own way, but constantly misunderstood by, well, by external systems, by observers.
Misunderstood. Is that where observer betrayal comes in? I saw that phrase.
Exactly that. Observer betrayal is, it's like the cognitive damage that happens when your own efficient internal logic gets misinterpreted, or worse, penalized by conventional external systems that just don't get it.
Ouch. Yeah, I think everyone's felt a version of that.
Right, so PASTA, it's essentially built to counteract that betrayal. It's engineered to see, and importantly, reward the specific, personalized logic of the individual user. It's the system that can get the inside joke.
So it adapts to the human rather than forcing the human to adapt to the machine. It validates that internal way of thinking.
Precisely. It validates cognitive autonomy.
Okay, so that's the software validation, a system built to understand you, even your inside jokes. But how do we grasp the depth of this connection? It still feels a bit like a coincidence.
Well, that's where the Eselsbrückes come in, the donkey's bridges. They're the tools to elevate this from just a technical alignment to something more like a conceptual truth.
Donkey's bridges. Tell me more.
They're essentially mnemonic devices, but more profound. Ways to make abstract ideas concrete, relatable, communicable. In this case, they use these powerful ancient Greek concepts to frame the whole thing.
Greek concepts. Okay.
Yeah, they take Verhage's personal framework and Hennigan's engineering blueprint and weave them into this single, unified story.
So what's the first part of the story? The union itself.
Exactly. It starts with the Hieros Gamos,
Sacred marriage.
the sacred marriage. It represents the union of the subjective, lived-in world, which the sources symbolize quite poetically as the tramp.
The tramp, like the wanderer, the outsider.
Sort of, yeah. The one with the rich inner life, but maybe misunderstood externally. And that subjective world joins with the formal objective AI world, symbolized as the lady.
The lady. Okay, so tramp meets lady. Subjective meets objective.
Right. And when that plea for personal understanding, the tramp, meets the objective technological blueprint, the lady, they don't just coexist, they form this unified creative whole, something new and greater than the parts.
That sounds almost romantic.
Uh-huh.
But it's grounded in engineering, right? So if that's the overall structure of the marriage, what's the thing that actually joins them? What yokes them together?
That's the next concept. Suzognomy. It means yoked together, or joined as one.
Okay, so what's the yoke?
The yoke is the shared principle of reinforcement learning, RL.
Okay. How so?
Well, Verhaeghe's neurobiological model, his description of his own cognition, pinpoints the basal ganglia as key for processing internal strategy and reward. And functionally, the basal ganglia operates like a biological RL engine.
Like nature's own reinforcement learner.
Exactly. And that biological system is directly, fundamentally mirrored by PASTA's IQL agent. PASTA is a value-based RL agent built in silicon.
Wow. Okay, so you have two systems, one biological, evolved, the other engineered, both fundamentally doing the same thing, solving the same problem.
Precisely the same optimization problem. How do you maximize individual value or reward or satisfaction over time based on learning from interaction?
That's a powerful connection. It suggests the internal logic, the tramp's way of thinking, isn't just quirky, it's mathematically sound.
It's computationally valid. That's the core of the Suzognomy here.
Okay, so we have the union, hieros gamos, and the shared mechanism, Suzognomy. What drives them together? Is there a force involved?
There is, and that's the erotes, the forces of desire, or the pull towards union.
Desire in AI.
Metaphorically, yes. The erotes are the parallel drives that make the hieros gamos necessary, not just possible. On the human side, the subjective side, it's presented as Mr. Verhaeghe's deep, almost existential need for validation, for his internal logic to be seen and acknowledged as valid.
Okay, that makes sense. The need to be understood.
And on the technological side, PASTA's engineered goal is to maximize user satisfaction. How? By truly identifying and responding to those latent, implicit preferences.
So the desire for validation meets the engineered drive to satisfy.
Exactly. There are parallel forces pulling towards the same point, ensuring this alignment happens, making the connection feel inevitable.
Wow. Okay, these Greek concepts really frame it powerfully. And bringing it back down to Earth, or maybe to the train station, there's that brilliant wordplay bridge too, right? Linking the tech to the human element.
Yes. The semiconductor and conductor Eselsbrugetschi. It's such a clever one.
Explain it.
Okay, so the semiconductor is the literal physical hardware, the foundation. It refers to this new kind of frequency switching neuristor tech that mimics brain function. We'll get more into that.
Right, the chip.
The chip. And that technical foundation is linked metaphorically to the conductor, as in a train conductor. Specifically, Mr. Hennigan, the AI researcher, is characterized as the conductor at Gare du Nord that does care.
The conductor who cares. I love that. It frames the whole engineering project not just as cold tech, but as something driven by a human imperative to care, to validate interaction.
Exactly. It bridges the physical signal processing in the silicon with the human processing of intentions and understanding. It's the ultimate reminder of the why behind the what.
It really ensures you don't lose sight of the human element in all the tech talk. A perfect Eselsbrugetschi.
Agreed.
Okay, let's shift gears then. Let's talk about that physical proof, the hardware itself. Because the semiconductor research apparently provides metaphors that validate the human cognitive model right down at the physical level. Let's look at autonomy and sparsity.
Right. This is where it gets really fascinating from an engineering perspective, too. The new Neurostor tech they discuss, it's designed with something called intrinsic plasticity.
Intrinsic plasticity. What does that mean in simple terms?
It means the artificial neurons can, and I'm quoting roughly here, autonomously adjust their responses based on their own past activity. They learn and adapt internally on their own.
Autonomously. So they're not just passively receiving signals.
Exactly. They're actively tuning themselves.
Yeah.
And this directly mirrors Mr. Verhaeghe's core idea of cognitive autonomy, the mind generating its own energy, its own strategies from its internal workings without needing constant external hand-holding or correction.
So going back to observer betrayal, that violation of autonomy, this hardware is like engineered from the silicon up to respect that internal logic, to trust the system's ability to self-adjust.
That's a great way to put it. There's a kind of built-in trust in the component's ability to adapt appropriately. And then there's sparsity.
Sparsity. Sparse neural networks.
A sparse neural network is basically one where most of the possible connections aren't active at any given time. It's not a dense, tangled web where everything connects to everything.
Okay, so if a dense network is like, I don't know, a crowded room where everyone's shouting, what's a sparse one?
It's more like a series of focused conversations in different corners. It relates to this idea of multi-monotropic thinking, being deeply focused on specific pathways, specific topics, or chunking information together efficiently.
Right, which in the neurodivergent model, that specialized focus can sometimes cause issues with general interaction, but you're saying the research proves this isn't a flaw.
Exactly. It proves it's actually a highly efficient architecture, not a bug, but a feature.
And there are hard numbers to back this up, right? The 27.7% thing?
Yes, this is the clincher. We're not talking small gains. The research showed that using this intrinsic plasticity in sparse networks allowed them to achieve the same level of performance as conventional dense networks,
Okay, same performance.
but using 27.7% less energy.
Wow, more than a quarter less energy. That's huge, especially now with everyone worried about AI's energy footprint.
It's massive. That percentage isn't just a number, it's a scientific argument. It says that forcing specialized, sparse ways of thinking into conventional, dense molds isn't just unhelpful, it's inefficient.
So this research basically provides objective proof that building AI systems modeled on this kind of efficient, sparse cognition, adaptive, autonomous, is actually better engineering.
It flips the script. It suggests specialized logic, when understood and supported, is superior engineering in terms of efficiency. It tells you, the listener, that if you process the world in a highly focused, deep, specialized way, that's not wrong. It's potentially a highly efficient architecture. It just needs the right environment, the right conductor to work with it.
Okay, that's powerful validation right there in the hardware specs. Now, the sources also frame this whole alignment, the Heros Gamos, the whole thing, as a fundamentally restorative act.
Yeah.
How does the hardware's stability connect to the human need for, like, cognitive recovery?
Yeah, this is another key feature of the Nurster hardware discussed. It has this ability to reorganize itself and restore performance, even if some of its components, some neurons, get damaged.
So it can heal itself, basically.
In a functional sense, yes, it demonstrates resilience. Now, think back to observer betrayal as a form of cognitive damage, like it shatters your confidence in your own internal system.
Right, it makes you doubt your own thinking.
Exactly. So the alignment with PASTA, this system that understands, acts as that restorative agent. It provides proof that your internal logic was sound all along. That validation helps restore performance, stability, confidence. The Heros Gamos, the union, is itself a healing process validated by the hardware's own resilience.
That moves it beyond just tech specs again, doesn't it? It touches on something deeper, almost philosophical.
Yeah.
The tech reflecting self-repair.
It really does. And there's an interesting, though maybe implicit connection here to the philosopher Thomas Reid.
Thomas Reid, common sense philosophy.
That's the one. Reid argued, very basically, that our minds come equipped with certain stable, built-in faculties, innate principles of common sense that let us perceive and reason reliably. We don't build everything from scratch.
Okay. How does the semiconductor connect?
Well, the semiconductor's intrinsic plasticity, its innate ability to adapt, self-regulate, and recover based on its own operational history, provides a really neat technological parallel to Reid's idea of the mind having these stable yet adaptive built-in faculties.
So the hardware's resilience mirrors a philosophical idea about the mind's inherent resilience.
Kind of. It offers this deep, almost philosophical grounding for the resilience shown in the human system. The fact that self-recovery is built into the very physics of the validating hardware. It's a powerful statement.
So, wrapping it all together, the PASTA project, validated by this hardware, isn't just a clever piece of AI. It's presented as proof. Proof that trusting your own unique, specialized way of thinking is actually warranted. It's a system built to see the human, counteract the misperception.
Exactly. It suggests that trusting systems and people to recognize that unique humanity isn't misplaced, that the conductor can and sometimes does actually care.
Wow. Okay. So we started this deep dive with these seemingly disconnected things, Greek rites, energy stats, feelings of being misunderstood.
Yeah.
And we used the very concepts generated by the sources IQL, sparsity, those Esels-Brigitschis, to see the connections.
Yeah, and we saw how this really deep, subjective struggle for validation found its mirror image, its technical justification, and maybe even its resolution in objective, state-of-the-art AI principles, both software and hardware.
The subjective human experience finding proof in objective engineering efficiency.
That's the core takeaway. And if we zoom out, think about the bigger picture. The insight here is pretty profound for the future of AI. It suggests the path forward isn't just about making things bigger, faster, more powerful in a brute force way.
Right. Not just scale.
No. It's about engineering systems, right down to the silicon level, that actually prioritize things like adaptive autonomy, finding efficiency in specialized sparsity, and building in the capacity for self-recovery.
Principles that bridge the gap between how humans actually think in all our diverse ways and building tech that's robust and efficient because it respects that diversity.
Exactly. It changes the whole conversation. Because if the AI, the future, is being modeled to learn the subtleties of our subjective world, right down to getting our inside jokes, well, it really forces us to look around and ask,
Ask what?
how much unique, specialized cognitive style, how many potentially super efficient, sparse networks are we currently penalizing or overlooking in the human world? Styles that AI is now being specifically engineered to reward.
That really flips things on their head. So the final thought for you, the listener, is this. What unique, sparse network are you running? What specialized, potentially highly efficient way of thinking do you have that maybe just needs the right environment or the right conductor to step in and finally validate its brilliance?